Okay gang, we're going to graph 2 periods of this one. So I'm going to start with the standard table that I showed you in the lecture. If you recall, I got the standard table from the unit circle. So I just, So I just went around the unit circle to get those values. Okay. Now, the only alteration to this is in the interior of the cosine function, which means it's going to affect the domain values. So there is a horizontal stretch on this guy. So the b value here is 1/2. The formula for the period is 2 pi over b. So if we plug into the formula, we get 2 pi divided by 1/2, right? So now I'm plugging this into here. I'm going to solve this out. So this is the same thing as 2 pi divided by 1/2. We're going to change this to multiplication. It's 4 pi. Okay, so the period is 4 pi, which means it's twice the horizontal length as usual, because the cosine function does one period usually in 2 pi, but now it's going to do one full horizontal cycle in 4 pi, so it's twice as long. Alright, so again, when b values only affect the domain, it's going to pull the x values farther apart, but the heights will be consistent. Alright, so now we're going to do the new table, right? We're going to convert the table, and then we'll draw it. Alright, so like I just said earlier, the y values have not changed. Let me just spread them apart a little bit. Alright, so it's going to still start at 0. You haven't pushed this graph left or right. And it's going to end at 4 pi. These angles aren't too difficult, so you could probably figure it out without calculating the increment. So I'll do it both ways so you can see it. So since these have to be equidistant, then halfway to 4 pi would be 2 pi. Halfway between this is pi. Halfway between this is 3 pi. Okay, so since those weren't difficult to calculate, I just showed you a quick way to sort of do it. The longer way is to calculate the increment. If the numbers are difficult, you definitely want to calculate the increment. And again, the formula for that would be the period over 4. So the period in this case is 4 pi. I would divide that by 4. So that means that the jumps are by pi. So I would start at 0. I would add pi. That makes pi. Then I add pi. Makes 2 pi. Then I add pi. Makes 3 pi. Then I add pi. That makes 4 pi. Okay, so it's that kind of idea. Okay, so now let's draw this graph. So really once you get the table set up, you've done really most of the work. You just now have to convert the table. Oh, sorry, if it loses focus, I'll fix it, okay? Once you get the table, it's really, you've done most of the work. The only other little thing you got to be worried about is sort of scaling it correctly, right? So, for instance, if I say like this, like the x values need to go by pi's, right? So we start at 0, we go to pi. So if I'm deciding to call that magnitude of pi. I could have called this magnitude of pi, or could have called this magnitude of pi, right? I'm deciding that's a pi to me, right there. So it's where all the graphs are pretty much going to look the same. It just depends if you're sort of zoomed out or you're zoomed in. Okay, that's like the major difference. It's the zooming. Oh, this battery is telling me it wants to be charged. Okay. Alright, now once you decide that's pi, you have to remember that pi is about 3 units. So that would be like 1, 2, 3, right? So 1 is about that. So because in the outputs I need units of 1. Yep. No. Because I need units of 1, I have to sort of relatively get this to match up. Alright. I don't need that there. Alright, and now we're good to roll. We'll do the first cycle, and then I'll add on another cycle, okay? So now I'm looking at the points. So I have 0 and 1. I'm going to put that on my graph. Pi and 0. 2 pi negative 1. 3 pi 0, 4 pi 1. Alright, so this is one cycle. Try to get the concavity right. It bends downward, bends upward. That's called concavity, a bending feature. A twisting is called concavity. In calculus, that's the second derivative, the concavity. This is called concave up. This is called concave down. You'll learn all about that when you go into calculus. Okay. Now they want 2 periods of this graph, right? So you want to, if this is what I'm calling the width of 4 pi, then about here is 8 pi. Half of that would be 6 pi. Halfway here is 5 pi. Halfway here is 7. Alright, and now you just want to repeat that again. By any chance if this video dies, you've got most of it, so I'll probably just leave it at this point. Now you follow it again. So if it's right, it goes up, middle, down, middle, up. Up, middle, down, middle, up. Okay. We might get it. And please don't leave it, to me this looks like a cut segment of the domain. Please pull it a little bit on each side, put a little arrow on it. This is a active function. It is going to keep oscillating, right? So you want to say like this goes on and on and on both sides. Put the arrow, please. Alright, so this is the final graph of y equals cosine of x over 2. 2 periods of it. Alright gang, catch you. Bye-bye.